So your test Thursday will cover everything that was on the quiz, and then everything that we worked on last week, and then there's a new lesson today, and today's your last lesson. That'll be on that test on Thursday. You have a question? Okay. All right. So we talked about function notation on Friday, and so we talked about function having names. Functions. So this function is called g of x, and we can name a function with any letter that we want. Most often they're f of x, f for function, but sometimes they're g, sometimes they're h. And then whatever variable is here in the equation, that should match what's in the parentheses. That's how you read function notation correctly. So when I read this g of 3, this means take x out. Take x out of the equation and replace it with 3. And in math, we start to get really creative with this. We'll put anything in those parentheses. Sometimes you have to replace it with another variable. Sometimes you replace it with a whole nother equation. Like sometimes we'll put equation in here, and you have to take x out and put another equation in the equation. Yeah, I mean, it gets really complicated, honestly, but so for g of 3, I'm going to take that g equation and put 3 in. And then we just have to be real careful about the order of operations. Dominic, what would you do first here? Yeah. So I'm here. G of 3 equals, I can put a line here and I'm just going to ignore this. I ignore the notation. I focus on here, the order of operations. What are you going to multiply? Tempting, because in PEMDAS multiplication. Nope. Yeah, right there. Okay, we are gonna do something with that little 2. What's the little 2 called? It's an exponent, so that's 3 times 3, that's 3 to the second power. So the first thing, order of operations, we're gonna do is the exponent. We're gonna do 3 squared, which is 9. So now we have -4 times 9. All we've done is one operation, and then I rewrite the whole problem, and this just leads to the most accuracy, rewriting each step of the way. All right, so -4 times 9, and then I'm going to do -3 times 3. Now I just have a lot of subtraction, and you're allowed to use a calculator, okay? So that's going to be -45 minus 7. -52. And then I love how you just said that. So g of 3 equals -52. So I want to see this answer written. You have all the work, and then I want to see g of 3 equals -52. So this part that I ignored comes down and is part of my boxed answer. And that tells anybody reading my work that I had a g function and I replaced x with 3. So number 2, even more difficult because of the extra negative sign. So now we have to do g of -1. put a line through it. Ignore this. I could have picked easier equations, but I thought you were up for it. But if we're going to practice this function notation, we might as well practice, you know, some tricky order of operations with it. All right, so Libby, what are we going to do first? So what is -1 times -1? +1. Okay, -4 times a +1 is a -4. -3 times a negative, +3. Question so far? Libby? What's your question? Oh, you said you have no question. Okay. What's the answer? That's right. So can you state the answer using the function notation? Yeah. So did you box this like this? Very good. Okay, we're ready. Sorry. Yeah, I'm walking around and seeing the answer. So on a scale of 1 to 10, how much easier is this one? 10. So I could have given you a worksheet full of these. You know? No, but I didn't. I gave you the more difficult one. Oh. With the exponents and the 3 terms and the. But this, you know, this is still eye level. So you know, I could have made all your problems this easy. Why not practice our exponents? Make it more difficult. So if you could do these, you're in a really good place. You know, if you couldn't do the last ones, maybe you felt overwhelmed. Those were challenging. If you can do these, then you're still in a good place. Maybe you can do it all. You're in a really good place. Okay. So for number 3, we can explain what it is that we have to do in number 3. Sophia, go for it.
So you write out 3 times 0 plus 8.
That's it. You take the s function, take the x out, replace with 0. Okay, and then I'm going to draw a nice line here, and I'm ignoring this because this is just like symbols that tell anybody reading my math what it is I've done. All right, 3 times 0 is 0. Add 8. Here's our answer. We're going to state our answer using our function notation. When x goes in, 8 comes out. Can anybody rate this information as an ordered pair? That might be a point on a line. Cadence?
0, 0, 8, x value is 0, the y value.
Yes, so this function notation really could look like y equals 8, right? F of x and y, same thing. So what I could see here is that if x goes into this equation, 8 comes out. So the input is 0 and the output is 8. So these are actually ordered pairs on a line that we're finding as we're going through this. So now we'll take the x out and we'll put -2 in, draw our line, ignore the left side, simplify the right, f of -2 equals 2. Looks good. So if that was written as an ordered pair, -2 for x yielded +2 for y. Questions? All right, let's see that worksheet then. Take a look at that worksheet. Alright, here's number 2, letter A and C. So if you could not finish, or you didn't do it on your own, you have my full permission to take pictures of the screen, and go back and make corrections, or test yourself again. Maybe start fresh. Could I do this again the right way? Like, I realized it didn't work, or I made a million mistakes. Could I do it again? All right, number 4, letter A. What did you guys get? Call it out. -2. And the letter C, what did you guys get? Okay, you're questioning. That's good. I'm glad you're questioning.
I think I did it wrong. Oh no. I did.
Did anybody get 112 here? Very good.
Oh my god. I just thought it was right.
So take a minute and look. Man, I didn't get 112. Where did I go wrong? Square it first.
Well, I did 3 times 6. I did 3 times 2 first, and then
So write down the correct answer. Take a look. What could I have done differently? Remember that exponents always come before that multiplication. Square your 7 and then multiply. Alright, let's flip. Anybody brave enough to call it their answer right now? Just say it. 39. What about C? 11.
I think I actually like that.
So 5 was the easiest equation on here. What made 5 so much easier? No, it's funny. So 5 is called linear. And the rest of them are called quadratic. So those linear equations are easier than the rest of those quadratic equations.
Is it quadratic because there's 4 steps?
No, it's actually quadratic because it's squared. And like a lot of people think, well, quadratic shouldn't be like a 4th degree, like shouldn't be power 4. But the area of a square of a 4-sided figure. I can't. Okay. So you know that when you have a square and you do like side length times side length, the area would be the side length squared. So when something's squared, we call it a quadratic because it came from a four-sided figure. A lot of people hear quad and they think it should be something to the fourth power. All right, here we go. Big reveal, number 6.
242.
74.
74.
Oh.
Oh, no.
Yeah, 242 on this one, right? I heard a right answer. Looking for a right answer.
Yes, I did.
That's where I messed up. That's where I messed up.
It's absolutely okay if you didn't get them right. Just go back and correct them. Number 7.
59.
You're filling 9, 10, 11, 12, 14, or 15.
What could you do if you want a little more practice?
New ideas.
You can look up problems on the internet.
You could do the B and the D option, right?
Oh, yeah.
So if you had a hard time with this and you have some questions, coming after school, do a couple of B and Ds, and I can look at your work and I can help you with it. And you can leave feeling good. Uh-oh.
That's minus 2 off the
Here we go.
Yes, ma'am.
Where's the F minus?
Right here.
Dang, already done.
Oh, these are the wrong number.
What is that?
80?
Shut up.
Okay. Alright, so this was section 7. What did we do with these things? Oh, we had to do the mappings and we had to decide if something was a function, tables, domain, and ranges, and then we did this. Alright, so today we're starting section 8, which is the last section of chapter 1. So go to your notebook. I have some notes for you. It's actually a lot to write down. So let's just get right into it. No, I'm serious. So serious. Look at it. You have to write all that.
Oh, man. That's fun.
No, but I'm gonna like even add to it. I think. I don't know. Let's see what we do.
Ben, you can't skip the notes. You obviously can't do the notes. I guess these notes.
You got to cheer on a DC.
I did not cheat.
Because literally it's both right in front of
You
you.
are so. It's funny because I didn't have my book that minute. I have my whole first week, so be quiet. You're lying.
So we're going to be interpreting graphs of functions. So last week we talked about, what makes a function. Does anybody remember the rule about functions? Yeah, every x has to be paired with y. And so the graph of a function, what's the test that we do to make sure it's a function? The vertical line test to make sure we don't touch in more than one place. Well, if you're looking at a graph of a function, there's lots of ways to describe it. So we're going to break it down. I think there's 8 characteristics of a graph that we're going to talk about. So I'm going to show you a picture of a graph, and you have to tell me all of these details. So this is details of graphs. It's really a lot of it's just vocabulary, really. So you must know these details. And again, this is 1-8 of your book. I do encourage you to read your book. So you must know the X-Intercept. How should I know this? Continue. Maybe gray?
Red.
I don't know why it's blurry, though.
Nobody asked us.
Can you read that? Is it too light?
No.
Maybe I hit a light. I want to turn the light off.
You can't see it.
Have you read the color purple?
You can read a color?
Would it cook?
I know.
Yeah.
You've read it?
Damn.
Purple.
Johnny.
Android.
The x value where the graph. Yeah, we're actually doing this. Crosses the x-axis. That's your x-intercept. You can't read that at all anymore on here. I gotta turn that light back on. Sorry about it. I agree. I could probably turn the backlight off as a compliment.
We cannot.
That's not fair.
Yeah. With the most back.
For some reason, the video when it's dark and then this is bright, it's blurry. Like the camera can't focus. Okay. No, I got something to say about this. It's not important today, but it's really important in the future. At all x-intercepts, y will equal 0. Let's not. That's too much. That's too much. Okay. Y-intercept the y value. I mean, somebody should be in here witnessing this writing blurry right now. It like focuses and then unfocuses.
Yeah. Well, if you like watch her write it really close, but it's not that serious.
It is blurry though.
It's still readable.
It is. It's legible. It could be better.
Even here with the light on, actually.
Okay.
Yes.
So symmetry. Does a graph have symmetry? Can it be folded in half? Is what you're answering here. Not all graphs can. We're gonna answer that. Can it be folded in half? And I'm gonna go ahead and say vertically. Like a hot dog fold, not a hamburger fold, if you know what I mean.
Fold the hamburger
You know what I meant,
Folds a
right?
hot dog in half.
Like with a paper, when you fold it down, that's a hamburger fold. When you fold it this way, it's a hot dog fold. You know what I meant, right?
Just likes to be extra.
Okay, is it linear or not? Okay, I really have to give you time to rate this because I haven't shown you these. I agree.
It's just like pixels.
It's a pixel issue. Linear or non-linear? Is the graph a straight line? Look, and it won't even erase.
What's happening today?
I don't know. There's the same reason it's blurry. You know what? Any IT person would tell me reboot. Just shut it down and restart it.
We don't have that type of time, bro. We don't got time for this.
The rest, I'm gonna reboot after I'm done in this period.
So next period gets the lights off and
Well,
Wow.
that is
So,
no, the blurriness isn't actually related to lights off. It's because I'm recording this right now. For everyone who's absent all day long. Yeah, but they can only hear, like, if you've ever watched the videos, you can only hear me when I'm standing right in front of it. Like if I stand right here, they can't hear me at all. So they can't hear
Good
you.
luck.
They can hear him. They can hear him. But they can't hear the rest of you.
What?
So I can say whatever I want.
Yeah, check them out. They're hilarious and entertaining.
So I can say whatever I want and they hear it.
Yeah, you're right. Next time.
Okay, so the graph is increasing, meaning it goes up left to right. Where is the graph increasing? Going upwards. We're almost done. Are you done with 4 yet? No? That's it. That's all 8. Those are the 8 characteristics. Too small?
Hey. Change your tone.
Missed my line though.
Change your tone.
Someone could make a math music video on this section. Showing graphs and their vocab would be easy.
Mikhail would be the best at
Are you near communication?
He raps sometimes.
That's
Or a building that was not called. If you have students needing a new ID, please send them to the media center at this time. You're at building 16.
So number 7.
36.
So a relative max is like a high point somewhere in the graph, and a min is a low point. I'll just give you an example.
Dude. What?
Tony, that was not on you.
Yeah. How dare you guys? That was not.
Everyone else.
He does rap. Yes, he has. I swear he has. Yeah. People don't have the right mind. Right.
So this little dip would be called a minimum.
Whoa.
Because it's a little dip. And then up here, this little hill, that would be called a maximum. That's what we're looking for a description. And the end behavior is what's happening on the left and the right of the graph. It's got a little dot here to indicate it's an abbreviation for maximum. Well, Maxim's a men's magazine. Does that still exist in the world? Maxim? It's a men's magazine?
I don't.
Magazines are just non-existent.
Kids these days don't read magazines.
You know, yeah. Like 10 years ago, Maxim was a popular. It must have been 20 years now, I guess.
It's not that old.
Maxim? You've heard of it? Yeah. It's not at Publix, so I don't know where you would ever see it.
Publix? They have magazines here?
Yeah.
Do you even grocery shop?
Actually, I don't.
You don't. You don't go to the store.
They got cute magazines,
Yeah, okay, I'm hearing you.
Now they got the news and stuff.
Really?
Yeah, next to the food.
Man, I am blind.
You are.
Yeah, you're just.
Well, it's okay if you don't go. Alright, so let's do this. I'm going to show a graph and we're going to describe all 8 parts of this. My problem is I can't show the questions and the graph at the same time.
Alright. Yeah, man.
I know one thing.
Oh,
There's our graph. We're gonna answer our 8 questions. I'm looking at that graph. I guess I'll do it on the board.
Wow, that's a big arch.
It's a gateway arch.
What about
So
the arch?
yeah, go ahead and picture how high does the arch go?
Pretty high.
580.
Do you think it's a bridge?
No, not even close. Oh, so it's 580 feet.
Yeah.
Okay, there's no way it's a bridge.
It's very high up, 580 feet. And then it's almost only half an arch in real life. I don't know about that. Looks like half an arch to me.
Where's the arch? I don't even know.
Legend says that that's how Russians got something.
Where's the arch thing, the building thing?
St. Louis.
Maybe that's it.
I swear it says in the Bible.
Okay, so number 1, what's the first characteristic we're supposed to describe? What was number 1?
The X value where the graph crosses the X.
Okay, so this graph has 2 X-intercepts, doesn't it? Not all do. This particular graph has 2 X-intercepts.
Dang, it goes all the way to 80 to 240.
And the X-intercept, so here's our X-axis. So our X-intercept, yeah, how is this going up? This is complicated. It's
pretty simple.
80 plus
580 in there, 580 feet in the air.
No.
we're talking about X-intercepts. X-intercepts are on the X-axis. 80, 160, 240. So what's this, you guys?
240 plus 160. 80. Just add 80.
320. At 320. Negative 320 and positive 320. Yeah, we're doing this all together. So it's going by 8s, right? So, it's 8, 16, 24, 32. That's how Logan came up with that. Great job. Number 2, what's the second characteristic we're supposed to be able to describe? Y-intercept. So this graph only has one Y-intercept. So all graphs are different. So just because I'm saying one Y-intercept and 2 X-intercepts for this graph, that doesn't mean that your graph that you're looking at matches perfectly. So a Y-intercept is where it crosses the Y-axis. So no, it's going up by 80s. It's going up by 80s. 8, 16, 24, 32, 40, 48, 50, 64.
Oh.
Good job.
I thought it was by 2.
Not by 2.
Yeah, it said 6, 8. I'm like, 20.
Oh, like times 2.
Jeez.
What the crap?
So maybe I'll highlight it. This was our Y-intercept up here. And these were our X-intercepts down here. And I picked a challenging graph where you had to kind of figure out the intervals and count. Those are going in intervals of 8. All right, what's the third thing we're supposed to describe?
Yes or no? Can it be falling?
Symmetry, yes or no?
Symmetry.
Jeez, you guys not look at your paper.
No.
You guys have the paper.
So does this graph show symmetry? Can we fold it over the hot dog way, the long way, and it'll match?
Yes, because it has the same X values.
Yes, this is symmetrical.
I heard you, Libby.
Who didn't hear her?
Wow,
Number 4. What's the 4th thing we're supposed to be looking at? Okay, does this make a straight line? No.
Yeah, I know. Thank you.
This is not linear. Because the line curves. Okay, so linear means it's perfectly straight. There's not a curve in sight. And this line has the So it's definitely not linear. Yeah, okay, so what's the fifth thing we have to describe?
Is it increasing? Going left to right.
It's increasing and decreasing at the same time.
At the
Not,
same time?
it is not linear.
No, it goes up and then down. Okay, it's not the same time. If it was same time, it would
It's getting different.
Hands off Pluto right now. Dude, I went to the bathroom.
It's the same answer.
But I don't understand.
Because you were saying
No, I was paying attention.
You should have seen when they came out. They were like,
Look at this. This is something that you don't come up with on your own. You generally need a little bit of help in figuring out how to describe where a graph is increasing. So it's increasing until here, and then it starts decreasing. Okay, so I describe this by saying the graph increases until x is 0. So here where x is 0 is where it takes a turn. So I'm describing that interval of the graph using the x-axis. So it increases from the left until x equals 0. What's the next one? So who could describe for me where the graph is decreasing? Okay, the graph decreases. Beyond x equals 0. Everything beyond x equals 0, the graph is then going downward. Decreasing. All right, what's the seventh detail we said we're going to have to talk about? Okay, this graph.
I'm talking about you.
I'm going to say at 0, 640. That's the maximum. X is 0 and y is 640. That's the highest point. You got a high point. It doesn't have a minimum. There's no dip. There's no low dip. Look, you skip it. No minimum. Maybe I write that. No minimum. Okay. And then what's the last characteristic? We have to break this graph down. Okay. Here we go. We're going to describe the end behavior. So the ends are the left and the right. So I'm going to say. I mean, you don't. Why am I here? The graph decreases on the left. The graph decreases on the right.
Dude, if you give me $10,
Yeah.
$10?
$10.
Oh wow.
What?
Yeah, let's all chip in.
Well, I can pay $10 just for you.
Okay, I've just noticed something that's confusing here. So it increases from the left, but it doesn't increase on the left. Okay, we're talking about the arrow. And this arrow is going down. So maybe it would be easier, and we're very open to the vocab you do in Algebra 1. I could say the graph goes down on the left. And do you agree with that arrow going down?
Yeah.
And on the right, the graph goes down. Because we're not talking about the line. This is confusing because I just got done saying it's increasing over here, didn't I? But on the far left, that arrow is going down. Why are you talking? Okay, well, write your
The
assignment.
belt is dismissing.
Okay, so in your workbook, there's 4 of these. There's 4 nice little graphs, and you it tells you like which descriptions to use. So use these notes and come in tomorrow with questions. We'll talk about it more. It's right on the backboard. You're gonna do this same thing with 4 different pictures.
So what was that?